Hi class, it's me, Mr. Morris, again with another video from our gas laws series. This is actually just finishing up the practice problems on the Charles Law set of notes. So I want to go down to this second example problem. My paper position where it's in good shape now. Okay, so our second example problem, we did the first one with the notes video. It says 4.40 liters of a gas is collected at 50.0 degrees Celsius. What will be its volume upon cooling to 25 degrees Celsius? So as always, I want to first annotate this. I'm going to break it down into data that I know and the question that's being asked. So I see 4.40 liters. I see 50.0 degrees Celsius. It asks me what the volume will be, what will be its volume upon cooling to 25.0 degrees Celsius. That's my last piece of data. Okay. This is Charles's law, so it's volume and temperature, V1, T1, V2, T2. So let's write that down. V1, T1, V2, T2. 4.40 liters is a unit of volume, and then 50.0 degrees Celsius is a unit of temperature. Looks like we're decreasing temperature. It says cooling, so that's decreasing temperature to 25.0 degrees Celsius. So this is V1 and T1, and that's V2 would be unknown in T2. So let's write that down. 4.40 liters. T1 is going to be 50.0 degrees Celsius. V2 is unknown, and then T2 is 25.0 degrees Celsius. Don't forget, anytime you're dealing with gas laws, we need to make sure that we add 273 to them. So 50 plus 273 is 323. So let's add 273.0. We get 323, and that's because I need to convert it to Kelvin. Okay, then we have 25 plus 273 gives you 298. .0 Kelvin. Excuse me. All right, let's go ahead and set up our formula. V1 over T1 equals V2 over T2. Oh, really didn't mean to put that there. That's okay. V1 over T1 equals V2 over T2. I'm going to scoot over because I think I'm going to run out of room if I leave it right there. So V1 is 4.40 liters. T1 in Kelvin, it's 323.0. Okay, over here I've got V2, which is my unknown, and then T2 is 298.0. Okay, easiest way to solve these problems, in my opinion, is usually cross multiplication, just because it's consistent. You can always do that and it'll work. So I'm going to do 4.40 times 298.0 cross multiplying. You get 1311.2. I'm going to need to round this to 3 sig figs at the end. 1311. Let's just call it 1311. Equals 323.0 V2. Don't forget, we're going to round at the end to 3 significant figures because I have 3 significant figures there. Okay, I want to solve for V2. In order to get V2 by itself like this, I need to divide both sides by 323. So V2 equals 1311 over 323.0. So 1311 over 323.0, you get 4.06. V2 equals 4.06, and our units for volume are going to be the same as they were in V1, so that would be liters. 4.06 liters. Let's move on to the next one. Example number 3. I've got 5.00 liters of a gas. It's collected at 100 Kelvin. 100 point, that means I've got 3 sig figs there. Kelvin. It's already in Kelvin, so I do not have to convert to Celsius. It's already there. I'm sorry, I don't have to convert to Kelvin because it's not in Celsius. It's already in Kelvin. And then it's allowed to expand to 20.0 liters, so it gives us our second volume. What must the new temperature be? What must the new temperature be if we were going to maintain the same pressure? So in other words, we're going to leave the pressure alone. That's constant. The only things that are changing are volume and temperature. So we're back to using Charles' law again. V1, T1, V2, T2. It says that we're going to be going through an expansion. It's going to expand. That means that the bigger volume is V2. So 20, that's V2. 5.00 liters. T1 is 100 Kelvin. Don't forget that little decimal there to make sure that it's clear. There's 3 sig figs. V2 is 20.0 liters. And our second temperature, it does not tell us it has to be in Celsius, so I'm just going to write it in terms of Kelvin when I solve for it. So I have volume in liters, I have temperature in Kelvin. I can go right into my equation, which is V1 over T1 equals V2 over T2. V1 is 5.00. T1 is 100 point. V2 is 20.0. And T2 is my unknown, so I'm going to just put T2. Now, this is one of those cases where the reason for it to be cross multiplication really makes sense, because I can't just directly solve for T2 by doing the reciprocal of what's happening here. I need to get T2 as part of the numerator. It can't just be in the denominator. I can't solve for it there. So a quick way of doing that is cross multiplication. There's other ways to think about that, but again, I think usually cross multiplication is the easiest. So 5.00 times T2, I'm going to get 5.00 T2. Very simple. And then 100 point times 20.0. Obviously, that's going to be about 2,000, right? It's 2,000. Well, I can't actually show 3 sig figs there, so I could go ahead and just do that to remind myself I've got more than enough sig figs here. I'm going to round to 3 sig figs in the end. That's what really matters, okay? So to solve for T2, I need to divide. I'm going to do 2,000 divided by 5.00. T2 equals 2,000 over 5 is 400. And again, 3 sig figs. I want to show 3 sig figs. How can I write 400 with 3 sig figs? Well, just put a little decimal at the end. Okay, and our temperature is Kelvin. And that's it. So, last 2 example problems of Charles's law. Next video, we'll be talking about a different law.